Hey guys, so many of you will already know about my Dr. Squiggles robots, and if not, I'll put a link down below so you can see more about what they are, but I currently have 8 of them working and then 2 more that are not working. I'm waiting on some parts so I can finish them up. And all they do is tap on things, but I've been wanting them to be able to play pitched instruments, to be able to play sustained pitches. So I've been building pipe organs for Dr. Squiggles to play, and this is, I guess, my first kind of prototype pipe organ. And then I have 4 of these prototype organ pipes in there at the moment, and these are kind of just, crappy prototypes, but they make for a good proof of concept. And I'll show you a little bit more about all this later in the video. But right now I just wanted to demo it for you because I've just finally over the weekend got it all wired up so that there's air coming into the organ and Dr. Squiggles can turn the pipes on and off. So I'll just play sound now through this big organ pipe at the front. And then, so right behind that one, there's this really tiny, high-pitched one, which I can play. That sounds like this. And then, so the other 2 pipes that are in the back there, this is what one of them sounds like. And this is the other one. And they all speak very quickly, so they can be turned on and off rapidly. And there's plenty of air pressure to play all of them at the same time, so this is what that sounds like. So obviously I haven't tuned them yet, but the organ pipes do have these tuning slides on them so that the length can be adjusted so that they can all be tuned. Okay, so I want to show you how this works a little bit, and it all starts down here. This big wooden box that I've got down here is the air supply for the organ. So it's basically just a soundproof box with a big CPU fan in it. And actually inside of there's kind of a wall, and the wall has a hole inside of it, and the CPU fan is attached to that hole. So basically there's a high pressure side and a low pressure side. And I also have a pressure sensor in there that measures the difference between the pressure on the high pressure side and the pressure on the low pressure side. And I also have a little microcontroller in there. And so this is what the inside of the air supply looks like. So there's the fan here, and then behind the fan you can see a wall, and the wall has a hole in it, and so the fan is blowing the air kind of this way through the box. And the high pressure side is on the other side of that wall. And then you can see the microcontroller here, and the pressure sensor is back in there, sort of buried in that bundle of wires. And then this is all just like soundproofing material, and then the outer wall of the box there. And so when I turn this on here, the microcontroller turns the fan on, and it tries to bring the pressure on the high side up to about 2.5 inches of water, of pressure. And at some point I calibrated that using this YouTube manometer, which I no longer have it hooked up, but it is filled with water up to about there. And when you hook this side into the high pressure side of the air supply, the water kind of moves around, and so one side of the water moves up and the other side moves down. And I'm looking for a difference of about 2.5 or 2.25 inches. So then the air comes out of this big pipe here on the side of the air supply, and I have it going all the way over here and down there, and then it's going into this junction box. And the idea of the junction box, the idea of the large hose is that because the air supply is a little bit loud, I want it to be as far away from the robot as possible. So I bring the air through this big pipe so there aren't too many losses. And then here, this will split the air out to the different individual robots. So I want to make 3 organs for 3 different robots. And right now I just have one hooked up and the other 2 are taped off, but eventually there'll be hose coming out of here going to the different robots. Okay, and then this black hose comes up here and then it goes into the back of my organ there. Okay, so, and then these holes are where the organ pipes connect into, and so each hole has a little fitting in it. This is what the fitting looks like, and there's a little black O-ring inside of there, and that's so that when you put the organ pipe in there, the pipe seals very nicely, and it's a completely airtight seal between the fitting and the organ pipe. Okay, and then at the bottom of each fitting there's a valve that looks kind of like this. So the idea is that this little round pad closes the bottom of the organ pipe like that. And yeah, so then when you apply voltage to this thing, basically it just the pad subtly pulls away from the bottom of the organ, of the pipe, and allows air to flow into the pipe. So here I'll insert a picture of what the bottom of this top surface looks like with all of the pipe valves attached to it. Okay, and then all of those wires from the pipe valve are basically soldered into this little connector that sits underneath Dr. Squiggles, and then that whole bundle of wires is going up into Squiggles' main controller board that's underneath this thing. And then just for the sake of demonstration, what I've been doing is I'm using my computer, which is connected via USB to Squiggles' main controller board. The controller shows up as a MIDI device in my operating system, and then here I'm using Reaper, but you could use any software that understands MIDI, and just by moving MIDI notes around, I can play notes on the organ. So. But there's also a Raspberry Pi computer inside of Dr. Squiggles, so eventually this thing will be autonomous. I won't need to connect my laptop to it. Just the Raspberry Pi that's in there can control, or will be able to control, the organ. So the way that I got these organ pipes is basically that I just wrote a script that generates organ pipe designs. And so this is just a web page, and I'll put a link to it down below so you can use it if you want. And the way this works is you just enter some information about what pitch you want your pipe to be, and some information about the material that you're using, and some stuff about the timbre of the pipe and so forth. And then this web page basically spits out 2 files. One is this 3D printer file, which you can just download that and 3D print it. And then it also spits out this laser cutter file, which you can download and laser cut that out of plywood. And so you can see that this bottom part of this pipe has been 3D printed, and that's just that file there, and then the top has been laser cut out of plywood, and this page has some assembly instructions. If you go to the question mark menu in the top right, it shows you exactly what to do once you've 3D printed and laser cut your pipes. And so my goal now is just to make a whole bunch of organ pipes of different pitches. So this pipe organ will just hold 8 pipes, but I'm going to have 3 robots, so I'll have a total of 24 pipes.